So I think you can track.
Hmm.
Okay, sure. Let's go for it. The question that I had given you was one minute. SF6. तो SF6 में क्या आ रहा है मोडी नंबर आपको?
6.
6. Very good. Perfect. So the hybridization will be sp3d2, correct?
Hmm.
Okay, super. And geometry will be octahedral, correct?
Yes.
Now tell me about PCl5, madam.
PCL size is 5. Modi number.
Super. It will be sp3d,
Hmm.
correct?
Yes.
Then F7 will be
7.
7, and hybridization will be S.
SP3D3.
Got it?
Yes.
Super. All the answers are correct. I will share you one more assignment on this hybridization. There are 104 questions that you have to try based on Moti number. Okay, if you do this 104 questions, then there is nobody in the world who can stop you from getting good marks in hybridization. Okay, it covers all the past paper questions of NEET, all the reference book questions, NCRT questions, extra questions.
Hmm. Yes.
Do it by the shortcut method of Moody number only.
Hmm.
Cool. Okay, so that completes our uh, one of the most important parts of the chapter, that is hybridization. Okay. Now the next topic that we have to study over here is again a very easy topic, but at the same time we need to learn it properly. The topic name is valence shell electron pair repulsion theory. Okay, it is abbreviated as Vsepr theory. So we'll write it down over here. Okay. So the topic that we have to do is called as valence shell electron pair repulsion theory. It is valence shell electron pair repulsion theory. Okay, it is abbreviated as Vsepr. 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 It is called Vsepr theory. Okay. So what does this theory tells us? This this theory tells us that there are different kinds of repulsion in a particular molecule or an ion, and they say that the valence shell of the ion or the molecule, it decides the shape of the molecule or the ion. Okay. For example, we have done hybridization of water, right? Okay. So if I just draw the geometry of water, you will say that the geometry of water was tetrahedral because the Moody number was 4. Okay, the Moody number was 4. So it has two lone pair and two sigma bonds. Got it?
Yes.
So the electrons which are present in a particular bond, whether it is a single bond, double bond, or a triple bond, they are called as bond pair electrons.
Hmm.
Okay. And the ones which I have shown in the yellow orbital, the green color electrons, they are called as lone pair of electrons. Now, experimentally, they have found that there is repulsion between this lone pair and lone pair. Now, can you tell me why there will be a repulsion between this lone pair of electrons? Then you will say that, sir, it is a very simple concept. that both the lone pair of electrons, they will have negative charge. And in physics, we have studied that the two like charges, they will always repel each other. So this repulsion between the lone pair of electrons, it is called as lone pair repulsion. क्या बोलना है मैडम उसे?
Lone pair repulsion.
Super. Now look at this. There will be repulsion between this lone pair of electrons and the bond pair of electrons. देखो O और H के बीच में जो इलेक्ट्रॉन्स होंगे उसे हम क्या बोलेंगे? बॉन्ड पेयर बोलेंगे. और ऊपर वाला तो लोन पेयर है. So this repulsion is called as lone pair bond pair repulsion. Now there will be repulsion between this pair and this pair. What will be this repulsion called as? Any idea?
Bond pair and bond pair. So like,
Perfect. It is called as bond pair repulsion because there are two bonds and the electrons present in those bonds are called as bond pair electrons. So here the repulsion is bond pair repulsion. Okay, superb. Now, if you have understood this, go for this one also. What will be this repulsion called as?
this is lone pair and bond pair.
Superb. It is a lone pair bond pair repulsion. So basically, we say that here there are three types of repulsion: lone pair repulsion, lone pair and bond pair repulsion, and bond pair repulsion. So the major crux of this theory says that there is a maximum repulsion. The maximum repulsion is always between lone pair and lone pair. Lone pair repulsion is the maximum, followed by lone pair bond pair repulsion, and the least repulsion is in bond pair. So they say that lone pair repulsion is the maximum. Got it, madam? This is the major theory point that we need to know. Okay. So suppose if I just name the repulsions as, say, this is 1, this is 2, this is 3, and this is 4. Can I say that lone pair repulsion is 1?
Yes.
So yeah, so I will say that repulsion 1 is greater than 2 because 2 is lone pair bond pair repulsion. Okay, 2 and 4, they are one and the same. They both are lone pair bond pair repulsions. Okay, and the least repulsion will be in 3 because it is bond pair repulsion. Got it?
Yes, sir.
So this is what we need to know. And then they say that the valence shell electrons, they decide the shape of the molecule. They arrange in themselves in such a way that there is minimum repulsion between them and maximum stability. Then they say that the double and triple bond, they are considered as a single super pair. Now, what are the applications? What are the applications of this, valence shell electron pair repulsion theory? If you carefully check, do you agree with me that the geometry over here is tetrahedral in water?
Tetrahedral. Yes.
Yes. Okay. So what is the bond angle in water? If it is a tetrahedral, the bond angle should have been 109 degree and 28 minutes. Correct?
Yes.
But then experimentally, it is observed that the bond angle over here is 104 degree and 5 minutes. Now think of a reason that, sir, this is a tetrahedral geometry, but still its bond angle is not 109 degrees. It is 104 degrees. Think of the reason and tell me what can be the reason for this. क्या रीजन होगा मैडम, बताइए, एनी आइडिया? Think of all the repulsions that are taking place over here.
Hmm. There is a, a lone pair bond pair repulsion
Hmm.
because of
Okay. So what will happen? Yeah. See, I will show you. I will just try to see if my video, if I can open my video. Look at this. If you understand the concept, now you will never forget uh, all this shapes. Okay, valence shell electron pair repulsion theory basically, tells us about the shapes of the molecules. Okay, I'm not able to start my video. Did something wrong? At last. See, before the video gets off, see, this was the geometry. If you can see this properly, this was the geometry of a tetrahedral. Correct? This is a tetrahedral geometry. Now, in water, you know that there are two lone pairs and two bond pairs. Correct? Two lone pairs and two bond pairs. So here there are not there. This is not a bond. Here there will be lone pairs. So I will put two lone pairs over here. I will put two lone pairs. Check. Now if you carefully check, uh, these two, the white color bonds, they are called bond pairs. Here, these two are the hydrogen atoms in water molecule. Got it? Whereas these two red color ones, can you see this? Two red color ones, they are lone pairs. So can I say there will be a lot of repulsion in this between these two lone pairs?
yes.
So they will try to go away from each other. See, I'm trying to pull them away from each other. So
Hmm.
when they do that, they will put pressure on this
Hmm.
bond pair. So
Oh,
this bond pair, can you see this? I'm squeezing them.
huh.
Okay. So earlier the tetrahedral geometry had a bond angle of 109 degree and 28 minutes. But because of this lone pair repulsion, these two bond pairs, they are squeezed up, and then experimentally it is found that the bond angle decreases from 109 degree 28 minutes to 104 degree and 5 minutes. Got it? So it is because of valence shell electron pair repulsion theory, which says that there is a lot of repulsion between these two lone pair, which puts pressure on these two bond pairs. So these two bond pairs try to compress themselves, and hence the bond angle decreases from 109 degree to 104 degrees. Got it, madam? Okay. So now they say that if uh now the angle, and if the angle, you know that this one minute, madam. Now the angle is 105 degrees. Okay. So the geometry will be tetrahedral. Okay. But the shape will be different. Valence shell electron pair repulsion theory says that this will help us to determine the shape of the molecule. So if I tell you that the geometry, okay, if I write the word geometry over here, the geometry and the shape will be different. Okay. So what will be the geometry of the molecule? Tetrahedral. Okay. Because the Modi number is 4, the geometry will be tetrahedral. But the shape of the molecule, okay, is called angular. Okay. It is also called bent. Bent is a word used in NCRT, or it is also called as V shape. In various books, it is given V shape. Okay, so the geometry is tetrahedral, but the shape of the molecule changes. So who decides the shape of the molecule? Lone pair decides the shape of the molecule. If you do not have any lone pair of electrons, the geometry and the shape will be the same. Like in methane, there are no lone pair of electrons. So the geometry and the shape, they are one and the same, that is tetrahedral. But in water, you know that oxygen has two lone pair of electrons. Okay, so because of lone pair bond pair repulsion, the bond angle changes and hence the shape of the molecule also changes. Got it, madam?
Yes, sir.
Okay, so now I'm going to give you one table which will help us to understand that when the shape, what will be the shape of the molecules for different number of you know sigma bonds and matlab bond pairs and lone pairs. Here the bond pair means sigma bonds. Okay. So here they say that here we'll write number
Sir,
of
can I
sigma
see
bonds.
the previous one?
Yeah,
The
yeah, sure, sure. Yeah, yeah. Just let me know once you are done.
mm,
Okay, just remember this that the shape will change if the molecule has lone pair of electrons.
mm,
The shape will be same as that of geometry. Okay, if the molecule does not have lone pair of electrons.
okay.
Just let me know once it is done.
Mm. So the shape and geometry of the compound will be the same if there is no lone pairs, right?
Yes, perfect. That will write over here. If the molecule does not have any lone pair, you remember the ones that I had given you for a homework,
Mm,
SF6, IF7, you must have found that there are zero lone pairs
mm.
over there. So
Yes.
when we will do, shapes over here, we will say that the shape and the geometry will be the same. Like SF6 का geometry क्या था? Octahedral.
Mm,
उसका shape भी octahedral होगा because there are no lone pairs. Okay?
yes.
Sure. Okay, so I'm making that table over here. What I will be doing it over here is just 1 minute. Uh, first we have to say that we'll say that yeah we'll say that how many sigma bonds are there. The first column will represent number of sigma bonds and mark this table very important. Okay, whenever you draw it, this then the second column will consist of lone pair. Okay. The third column will tell us about its shape. What will be its shape? Okay. And the fourth will be its example. Okay. We can write one example of the same. Okay. So first, allow me to fill in this table. Uh, you can have 2 sigma and 0 lone pair. You can have 2 sigma and 1 lone pair. Then we'll have 2 sigma and 2 lone pair of electrons. Then 2 sigma and 3 lone pair of electrons. Then we will have 4 sigma and 0 lone pair, 4 sigma and 1 lone pair, 4 sigma and 2 lone pairs. Okay. Then 5 sigma and 0 lone pair, 5 sigma and 1 lone pair, 5 sigma and 2 lone pairs, 6 sigma and 0 lone pair, 6 sigma and 1 lone pair. Then you have 7 sigma and 0 lone pair. Got it? So these are the cases that we have to do. Just count along with me whether we have done 16 cases or not. 2, 0, 2, 1, 2. So these are 2, 3, 4. Ah, sorry, I made a mistake. We have to write 1 minute. We have to write for 3, 0 also. तो ठीक है वो बाद में मैं लिख दूंगा. ओके, वो यहाँ पे लिख देते हैं। अ, यहाँ पे लिख देंगे दिस विल बी से सिग्मा, देन लोन पेयर, and then the next one will be the shape shape of the molecule, and the last one will be the example. So this case is remaining 30 wala, 30, 31 and 32. Okay, so let's fill this table. If you have 2 sigma and 0 lone pair, okay, uh, can you tell me what will be the Modi number? 2 sigma and 0 lone pair, Modi number क्या आएगा?
2 sigma plus 2.
2, वेरी गुड। और लोन पेयर 0 है, देखो, कैन आई से दैट द लोन पेयर इज 0? है ना? तो मैंने क्या बोला था, जब लोन पेयर 0 होता है तो ज्योमेट्री और शेप क्या होता है, सेम होता है। तो जब मोदी नंबर 2 था तो ज्योमेट्री क्या था? लीनियर था, देखो लीनियर, है ना? तो यहाँ पे भी लीनियर ही आएगा। ओके, एंड व्हाट विल बी द एग्जांपल्स ऑफ द सेम? द एग्जांपल्स फॉर देम will be say आप BeCl2 ले लो, will write only one examples. Okay, there are various examples but will write only one as of now. Okay, then 2 1, 2 sigma and 1 lone pair अगर है, 2 sigma और एक lone pair है, तो ये है ना, आपको याद रखना है, इट इज कॉल्ड एंगुलर। अब ध्यान से सुनना, जहां पे भी हम एंगुलर लिखते हैं ना, वहां पे बेंड और वी शेप भी आ सकता है। क्या आ सकता है मैडम?
Bend and V shape.
हाँ, बट राइट नाउ आई डोंट हैव स्पेस इन दिस शेप वाला कॉलम, बिकॉज इफ आई राइट देन वो एक्सटेंड हो जाएगा, तो फिर एग्जाम्पल लिखने को जगह नहीं मिलेगा। बट रिमेंबर दिस, जहाँ पे भी एंगुलर है वहां पे बेंड और वी शेप आप दोनों लिख सकते हो। इफ यू हैव 2 सिग्मा एंड 2 लोन पेयर ऑफ इलेक्ट्रॉन्स, तो वापस आप एंगुलर लिखोगे। आपको भी पता है, जहां पे भी एंगुलर में लिखूंगा यहाँ पर भी आप बेंट और वी शेप लिख सकते हो। 2 सिग्मा 3 लोन पेयर इज अगेन लीनियर, अगेन लीनियर, बराबर है ये। देन 4 सिग्मा एंड 0 लोन पेयर है, तो इट विल बी टेट्राहेड्रल। देखो यहाँ पे मैंने बोला ना, यहाँ पे क्या बोला मैंने, कि देखो लोन पेयर 0 है तो मोदी नंबर 4 आएगा। तो मोदी नंबर 4 मतलब ज्योमेट्री टेट्राहेड्रल, तो शेप भी टेट्राहेड्रल ही रहेगा। नाउ लेट मी गिव यू एग्जांपल्स ऑफ ऑल ऑफ देम। इसका एग्जांपल आप SO2 ले लो, एंगुलर में, फिर 2 सिग्मा 2 लोन पेयर है तो आप वाटर ले लो, वाटर। ओके, और 2 सिग्मा 3 लोन पेयर है तो आप XeF2 ले सकते हो, I3 माइनस ले सकते हो, है ना? तो ये आपको पता होना चाहिए। 4 0 यहाँ पे आ जाएगा मीथेन। फिर 4 1 है, 4 1 मतलब 4 सिग्मा और एक लोन पेयर है, तो द ज्योमेट्री विल बी सीसॉ। ओके, ये सब मैं एक्सप्लेन करूंगा, राइट नाउ वी आर जस्ट फिलिंग द टेबल। एग्जाम्पल विल बी SF4। अगर 4 2 का एग्जाम्पल है 4 2, तो देन इट विल बी स्क्वायर प्लेनर, इट विल बी स्क्वायर प्लेनर, एंड द एग्जाम्पल इज XeF4। ओके, 5 0 का एग्जाम्पल है 5 0। तो कैन यू टेल मी व्हाट विल बी द मोदी नंबर 5 0 में? व्हाट विल बी द मोदी नंबर?
5.
5, तो 5 मतलब ट्राइगोनल बाई पिरामिडल होगा ना ज्योमेट्री, एंड सिंस द लोन पेयर इज 0 तो द शेप विल बी ऑल्सो ट्राइगोनल बाई पिरामिडल। बराबर है मैडम? इज इट करेक्ट?
Yes.
ओके, ओके, तो दिस इज व्हाट वी नीड टू नो। देन 5 1 का जो एग्जांपल है 5 1, वो याद रखो, इट इज कॉल्ड स्क्वायर पिरामिडल, इट इज कॉल्ड स्क्वायर पिरामिडल। phi 2 का एग्जाम्पल, अच्छा यहाँ पे एग्जाम्पल्स भी देना है ना। ट्राइगोनल बाइपिरामिडल का तो एग्जाम्पल आप पीसीएल फाइल ले सकते हो। स्क्वायर पिरामिडल जो है तो BRF फाइल ले सकते हो आप, BRF फाइल। ओके। देन phi 2 का एग्जाम्पल, मतलब पहले शेप विल बी पेंटागोनल प्लेनर। इसका एग्जाम्पल देखो ऐसा आएगा XCF5 माइनस। ओके 60, द geometry and the shape will be octahedral. ओके एंड द एग्जाम्पल यू कैन राइट अगेन SF6 जो मैंने होमवर्क में भी दिया था। 6-1 का एग्जाम्पल मैं दूंगा, बट पहले इसका शेप करना है, जिसको हम बोलेंगे डिस्टॉर्टेड ऑक्टाहेड्रल। डिस्टॉर्टेड ऑक्टाहेड्रल, XCF6। 7-0 का जो एग्जाम्पल है, इसको हम बोलेंगे पेंटागोनल बाई पिरामिडल। पेंटागोनल बाई पिरामिडल। TBP इज ट्राइगोनल बाई पिरामिडल, PVP इज पेंटागोनल बाई पिरामिडल। बराबर है ये? समझाइए, और एग्जाम्पल देखो, इसका एग्जाम्पल IF7। गॉट इट मैडम? ओके। नाउ इफ यू केयरफुली चेक, 3-0 का भी तो देना है एग्जाम्पल। 3-0 का जो शेप होगा, ओके 3-0 का जो शेप होगा वो होगा ट्राइगोनल प्लेनर। ट्राइगोनल प्लेनर and example will be BF3 will be the example. Okay. 3-1 का example is trigonal pyramidal. Trigonal pyramidal. Example is NH3. And 3-2 का example is uh, either you can write T shape or you can write bent T shape. थोड़ा सा bent होता है वो because of lone pair repulsion. TLF3 ले लो आप। समझाइए? Okay. So what I want from your side is just complete this table first, and then I will prove each and every example that we have written on the board. Okay. Just copy down this table first. पहले table लिख लीजिए। You are able to see it properly, or should I zoom in?
I can see, sir.
Okay.
I can see.
Okay. Okay. Just let me know once it is done. Okay, madam. Wherever the lone pairs are zero, just remember them, that the geometry and the shape will be one and the same.
Done, sir.
Yes, 1 minute. Okay, sure. So let's take the first case now. First case. What was the first case, madam? The first case was of 20. 20. Okay. I will write it down over here. The first case was of 20. First, let me just put this in one entire box. तो 20 का एक एग्जांपल क्या दिया था मैंने आपको? BeCl2। ठीक है, तो अपने को BeCl2 के बारे में पढ़ना है अभी। ओके, जस्ट गिव मी 1 मिनट। BeCl2। So let's take one by one. If we take BeCl2, okay. So the first example that we have to take is BeCl2. BeCl2 is an example of what? 2 sigma 1 lone pair. Got it? So what will be the geometry? See, the geometry will be linear and the shape will be also linear because there are no lone pair of electrons. Got it, madam? Okay. Now the next one was after BeCl2. 2 1 वाला एग्जाम्पल कौन सा था? SO2। SO2। तो SO2 का अगर आप ज्योमेट्री देखो तो it will have something like this and it will have one lone pair. It will have one lone pair. So if you carefully check, I will just try to show you this. As I told you in this valence shell repulsion theory, that is valence shell electron pair repulsion theory, मैंने बोला था ना ये जो डबल बॉन्ड्स है they are also considered as a single super pair. Okay, they are considered as single super pair. So I will just show you this one. If you carefully check, it is something like this. When we try to find the shape of the molecule, we don't consider the lone pair. For finding the geometry and the structure, we find lone pair. But for finding the shape of the molecule, we do not find, we ignore the lone pair of electrons. If you carefully check, this atom is sulfur. These two are the oxygen atoms. Okay, there is a double bond over here. You can just imagine there is a double bond. And what is this, madam? What is this? This is lone pair ना? This is lone pair. जो अभी मैंने आपको डायग्राम में ऊपर बताया ना, ये ऑरेंज कलर वाले ऑर्बिटल में दिख रहा है आपको ये वाला?
Yes.
तो दैट